Hey guys, welcome back to a new video. In the last video, we discussed about the enantiomers with taking example of uh, you know the glucose and alkyl glucose. Just looked into the enantiomers, and in today's video, we're looking into uh, another concept that is uh, you know that is about the diasteamers. We're looking into diasteamers, and we're looking into what are diasteamers. And in previous video we looked into the epimers. So I do hope that you got the concept of epimers. If you are having the concept of epimers, so this would be kind of easy to understand. Sorry, if you haven't checked the video of the epimers, do check that out. And in today's video, looking into uh, the diasteamers. So we're looking into diasteamers. uh, we'll take an example and understand the whole topic. You can write definitions from your registers and all that, but we're looking into the concept. Diasteamers, right? So uh, for this, let me take an example of two aldohexoses. We looked into what are aldohexoses. We looked into different type of aldohexoses, and we just looked into the structure of mannose and galactose. So we are taking these both over here to understand what are diasteamers. And if you haven't checked that video, do check that out, because we are running through a series of biomolecules, and the every previous topic is linked with the other one, the upcoming one, and while upcoming one is linked with the previous one. So uh, here I do draw first of all galactose, like C6, 1 2 3 4 5, and over here it is 6. And it is, as we know, that this is first of all in inner bonds between them. And we know that galactose is, so let me write galactose so that you don't get confused. Galactose, and as we know that this is aldohexose, so we have got that symbol of how we determine that whether it is aldose or galactose, or sorry, aldose or ketose. So that is this C1 atom arrangement, like carbon and hydrogen. This shows that this is aldohexose. Now we have got bonds over here. Let me draw the bonds, and here would be H2OH. This is also permanent, the last carbon. And over here we are having yes, okay, so on the first we are having the same C2. OH will come on this side, and the C3 is always changing aldo hexoses. So here would come the H, and here HO, and here H. Now what will happen in the galactose structure? We have seen that there is a difference on C4 as well. So here H will also come. Like in normal condition we've got OH, but now on C4 H will come as well. And here would be the same OH. We've got difference on C4 this time. Okay, so this is how galactose is. And if you do look into the mannose, mannose right? So here is a mannose one. Is also aldohexose, or C6, and the first and last arrangement would be similar. Make that we've got some difference in mannose. Here is a double bond oxygen, showing this is aldose. We've got hydrogen, and here we've got H2OH. Now do remember that in manuals we have got the difference on C2, like here would be H instead of OH, here would be sorry, HO. These are different. We looked into these differences in our previous videos. Do check them out to understand the concepts. Here would be the C3 is always different, and that would be H and HO, right? HO. Here the other remaining part would be the same. Here C4 is like the one which is in normal conditions, and this would be also the same. This is being the structure of panels. We are done with it. And what differences do you find? Do let me know. uh, I'm just highlighting the differences. Okay, if you see the differences both, the C1 is the same, right? They have both got aldehyde hexose, right? On the C2 we have got a difference, like here the arrangement is different. This is and this is different, right? The first change we have seen is this. If this is only one change, we looked in the video that if in this compound there is a single change, this would be called as epimer. So in this condition they're called epimers. But let's look further on. Are there any other changes as well? C3 is same, right? C4, we have got a difference on C4. And here comes the second difference. Now it is no more epimer, because in epimers we have always got a difference of single atom, and we have got two atoms different arrangement. C5 is same and C6 is same. Now two differences, two differences. Sorry, two differences. This means that these both are, these both are diasteamers to other, diasteamers to each other. Like we have got difference of arrangement of carbon atoms, uh, arrangement of more than one carbon atom. That is termed as diasteamer. Okay, I do hope that you learned something, and I've got your concept about the example, and meet you guys in the next video. Till that, goodbye.